Hello? Oh, so looks like we're live. So first off, hello, welcome to Oculus Connect 3. My name is Parrish with Epic Games, and today we're going to be taking a look at some of the newest features of Unreal Engine 4. Some of the things that I'll be showing you guys today are out now as of the current version of Unreal, which is 4.13. Some of them are coming soon. Once we get all wrapped up, we'll take a few questions, and we're also going to take a look, a short look at our latest project, Robo Recall. So jumping right in, obviously 2016 has been a massive year for VR in general. I mean, this is the year that the hardware has made it into the hands and onto the heads of the consumers, right? We've seen Rift, we've seen Vive, and PSVR are all going to be in our hands by the end of the year. Oculus Touch is out. Mobile VR continues to grow. Daydream is now a thing. And over again, Unreal has been the tool of choice for award-winning devs. It has a massive tool set, seamless hardware integration. Most of the stuff that you care about in terms of your VR hardware is just going to work. And we actually go out of our way to make sure that you don't really feel the pain of that integration. We have, of course, the unparalleled visual fidelity that Unreal is known for, and reliable performance that VR apps will demand. And there have been a lot of titles this year. I wanted to actually have a complete list of all the Unreal VR titles, and couldn't do it. It was totally impractical, so I just kind of did a really abbreviated list. But there's some real standouts here. Henry, which of course won an Emmy Award this year. A lot of shooters coming out. Obviously, we had Damaged Core, Killing Floor Incursion, and Raw Data. Actually, some of those guys were just talking in the previous panel, if you didn't see that. We've been into the depths of space with Adrift and seen some really artistic inspirations with Dear Angelica. And of course, the shameless plug for Robo Recall, which I cannot wait for you guys to get your hands on. If you have not yet played it here at Oculus, you should try. So Robo Recall, really quick, it is the evolution of the shooter action game that we brought to Oculus Connect last year with Bullet Train. It's exclusively on Oculus Rift. It's compatible with Oculus Touch and is going to be free in the first quarter of 2017. Now, from the technical side of things, kind of moving away from the, hey, coming soon, video game marketing kind of stuff, it is the first Epic shipped title that is going to utilize our forward rendering path, which is something I'm going to talk a little bit about here in just a few minutes. So how does Unreal make all of this kind of stuff possible, all these titles, including ones that we're making? And the answer is with a whole slew of VR-centric features that we put into the engine to make your lives easier and to make performance something that you don't have to fight so hard for. You're still going to have to make trade-offs. That's the name of the game right now. But we're trying to make those trade-offs a little easier on you and help you not have to compromise quite so much. So kind of from a top to bottom, we're going to talk briefly about all these. We have touch support, which good news is that just works. We have a late input update to lower the amount of perceived latency as you move your touch controllers around. Real-time GPU profiling, better UI support, hidden invisible area meshes, which I'm actually going to break down in a few minutes and show you kind of how those work. Instant stereo rendering and multi-view to make the most of the draw cycles as a part of your draw calls. Monoscopic rendering, which is a coming soon feature, super frustum culling, and of course the forward renderer. Now, we also have some VR development tools that are built right into the engine. If you're just getting started with a project and you want to prototype things, we have a VR template to help get you started very quickly. And we also have the VR editor, which allows you to build your worlds entirely inside the visor if you choose to do so. So let's take a quick run through of some of these features. So starting at the top with touch support. Just a quick note, if you missed it already, I'm sure nobody here missed it. This is just one of those things for later on. Touch is going to be pre-order on October 10th, and for sale December 6th. I've already pre-ordered mine, sort of. Can't wait. I'm just sitting here spamming. So this works with Unreal Engine 4 natively. It's just straight out of the box, plug it in, and it's already there. This is because we abstract the motion controller out. So we actually have a motion controller component that you can drop on your playable pawn. And your motion controller is just there. You just have to tell it what hand you're operating. And then if you want to add a mesh to it to make the hands visible, like your own skeletal mesh or a block or a punching glove, whatever you like, you just parent it and everything just works. Now, it has been abstracted out. So if you're developing for multiple VR platforms, it'll just work for those two. You only have to architect that once. You don't have to have one setup for Rift and another setup for Vive if you don't want to. At the same time, if you need that kind of support, if you need your game to change its behavior based on if you're running through a Rift versus a Vive, we actually expose that functionality as well. So you can make those kind of changes. Say, for instance, if you have an experience where you need to be able to see a touch controller in the player's hand versus a Vive controller. And of course, you can just jump in and play with this. It's very easy to set up inside of Blueprint or C++. Now, the next feature is late input updating. This is really just kind of an improvement to the way we were doing things. The diagram actually tells more about it than I can. This is kind of a breakdown of the CPU game thread versus the render thread. And the red line you see is how we used to handle input updating and kind of where along that path we used to do it. So what we've started to do as of this year is we push that off, and we only update that right before we draw the frame. And this lowers perceived latency. So the inputs will feel a lot faster and more responsive. Now, another here now, but also upcoming feature, it's an experimental phase. And if you haven't yet, I'm just curious, and I can't see any of you, so I'm just going to trust those of you who are raising your hand because stage lighting. Is anyone here using Unreal Engine 4 right now? Oh, cool. Most of you. Awesome. I'm among friends. So if you've seen like our experimental features, there are things that we are still working on in the engine. They're not always guaranteed to work flawlessly. But here's a new one in 4.13. It's Realtime GPU Profiling. If you haven't yet played with our GPU profiler, you definitely should check it out. Control, Shift, comma in any of your games, and it'll capture a single frame and tell you what the GPU did on that frame, which is great for a frame. But if you'd like to get kind of an idea of those GPU costs while you fly around in the level, that's why we've added a real-time profiler. Again, it's experimental. If you want to go home and play with it right now, there's a couple of commands you've got to put into the console. It's are GPU stats enabled? Then set that to 1, and then you can just do stat GPU, and this will pop up. In the future, once this becomes a real boy feature, then it'll just be stat GPU, and you won't think about it anymore. Another one is improved UI support. Figuring out the best way to do user interfaces inside of VR is always a challenge, and we're trying to make that as easy as we can. So 3D UMG widgets now work very smoothly in VR, and we have a new widget interaction component that you can attach to anything you like. You can attach it to the HMD if you want to have look-based interaction, or attach it directly to a motion controller if you want to aim it around. And essentially, what it is a laser pointer that you can point at something and then send the input of your choice down to it. So you can emulate a mouse click on a button, that sort of thing. And as you can see in the kind of demo video, it makes interacting with these 3D widget interfaces very quick and easy. So next, we have hidden and visible area meshes. Now, when you think of rendering a VR scene, inside the HMD, if you think of the whole thing as a single screen, there's a lot of wasted pixels because you're drawing just the shape of the lenses, and you got a lot of black, useless space on the outside. And so we intend to incur cost from these extra pixels from 2 angles. One is that we had to draw them in the first place, and then we actually have a post-process layer that had to process those as well. And each of those 2 problems needed to be handled individually. So we have hidden and visible area meshes, which are 2 different things. Now, this was already discussed by Alex Vlachos at GDC 2015. And the idea is that you have 2 separate meshes. The first one is a mesh that hides out the unnecessary pixels, which you can kind of see here on the right-hand side. It just blacks out everything and keeps that really close to the view so that all of those pixels fail on the depth prepass. So they never even get passed to the GPU for render. Now, when we draw the scene, any pixels that were masked out, again, they get rejected, so we don't have to worry about those. But the thing is, after we finish this, we didn't get the big gains that we'd really hoped for after we got everything integrated. And it turns out a lot of our biggest rendering costs were in post-processing. So the second solution became necessary. We also use a visible area mesh, which is kind of the same thing in reverse. So we have a mesh that completely covers up the area of just the lens, and we constrain our post-processing just to that location. Now, this was put together and integrated for Bullet Train last year, and it's been tweaked and perfected throughout the course of 2016, and it saved us about 0.3 milliseconds on Bullet Train. Now, another big one is instant stereo rendering. We've continued to work on this, and as of 4.13, it's just natively on. It's just something that is already switched on. You don't have to go digging for it. The idea is that previously, the way we were drawing our scenes in VR was very straightforward. It was draw the left eye, draw the right eye, which is fine because it's easy to integrate, but it's also twice as much work on the CPU to figure out what it's going to send up to the GPU. So at SVVR in 2015, Timothy Wilson proposed the concept of instant stereo rendering. Why not let the GPU instance everything off and then just incur a single draw call for both lenses? So generally, the idea here is you're saving CPU time because you don't have to do that double drawing. Now, this is something that, again, it is on natively in Unreal Engine 4, but it's also important to make sure you do a test case with your content if you want to use it, because this is going to be a fairly large benefit for higher draw call scenes. If you have a very low draw call, a very simple scene, it's possible you won't actually see a benefit. I'm not going to say you would see a loss, but understand that there is an overhead of just having this system on. So on your simpler scenes, try it with and try it without, and then judge for yourself whether it's a feature that you want to integrate. Really quick, let's walk through how it works, though. So here's a simple scene that we want to draw. And the first thing instant stereo rendering does is it draws the geometry twice. So we instance it off, one instance for each eye, but it's a single draw call because of instantiation. Then because we had it scattered across the entire viewport, we scale it in by 50%, kind of crush the entire scene down, then translate each eye so that each one is in the proper position. Once that's done, we use a clipping plane to cut off what the opposite eye shouldn't see, and then we're done. Now, this feature was originally created for Bullet Train last year, gave us massive savings. We saved 1.5 milliseconds on the CPU because we didn't have to handle both the draw calls to send up to the GPU, and it saved us about almost a millisecond, give or take, on the GPU itself. But Bullet Train was approximately 2,300 draw calls, and it was a lot of work to pull Bullet Train down to that. Just as a kind of a quick aside, there was a lot of condensation throughout that project to shrink things down, instance off a lot of meshes, combine meshes into a single thing to pull it down that far. Now, another feature coming up which doesn't have a fancy picture is multi-view. So this is kind of the same thing. This is an OpenGL extension that does the same thing for draw calls. This offers kind of that similar approach, but it's geared more toward console and mobile, where the cost of draw calls is even greater because you've only got so much CPU power to work with. Now, multi-view is currently working on PS4, and it is coming soon to mobile. Another coming soon feature in Unreal Engine 4 is monoscopic rendering. So this is starting to show up in the engine already. It's currently a work in progress. The idea is similar to what CCP did with Eve Gunjack. If the stereoscopic difference from one object to the next is less than a single pixel, then we just render that like a 2D object. We don't worry about drawing both sides of it. So again, currently this is only a mobile feature, but we're going to be porting it to the Forward Renderer. So you will be able to use it on desktop as well. Another coming soon feature is super frustum culling. So there's an init views pass on the CPU, which is determining what objects have been culled before you actually draw them out. And the way we're handling that right now is once for each eye. So we kind of go back to another version of the same problem we had prior to instant stereo rendering. We're solving culling in two different eyes. So we're trying to cut that down, and instead we're going to handle culling calculations based on a single super frustum positioned right between the eyes. So one frustum, slightly wider field of view, use that to figure out how the culling is going to work, and then send that up to the GPU. The idea is to get the GPU going faster so that there's less of a wait time for the GPU to start doing its job. So let's talk a little bit about the Forward Renderer. Lots of folks are excited about this. I'm very excited about it. Just a few things that I think are important to talk about early, though. So early this year, if you're reading about it, I think in May, Oculus released a forward renderer for Unreal Engine 4. Now, that was very cool, but the idea that they went with was to take our renderer and rip it out and put it someplace, and they put in their own renderer. What we've done instead is we have built a forward renderer on top of our existing renderer. You'll simply, when you switch over to the forward rendering path, what you'll do is switch off the bulk of the gbuffer. In fact, the entire gbuffer except for the depth prepass. We still keep the depth prepass so that we can use it for various rendering calculations. But our goal is to build on top of the work that's already there and not do a full replacement. The reason for this is that the Oculus forward renderer was very feature limited. It had really stripped out a lot of the features of the renderer to make it possible. If you had stripped out the same number of features from our deferred renderer, it's actually quite likely that performance would have been about the same. So we're trying to go a slightly different route. But because a lot of people already are asking me about this, it's important to drive home that the forward renderer is not going to be a magic bullet for performance. You will not just turn it on and things will not just magically work better or magically look better. You should think of it as more of a feature trade-off. Now, all that said, we are using it in this game, Robo Recall. So we're using it in Robo Recall, and we have discovered that it actually is making our content immediately look better and immediately run faster. So yeah, that's happening. But again, our goal is to make sure that people understand it's not like this is going to be the new path to do all of your work on. It's definitely a feature trade-off. It's something you should be thinking about as an option and not the way that you'll be working moving forward. It does actually require a few changes to your artist workflows, too. So if your artists are doing really cool things with shaders that require the gbuffer, keep in mind that goes away. So those really cool features and tricks go away as well. Now, again, this is battle tested for Robo Recall. And one of the biggest advantages of switching to a forward renderer is now that you have geometric edges once again, you can start using MSAA to get nice, clean anti-aliasing. Now, that's great for hard edges and architecture. It also has the possibility, not something we're doing on Robo Recall right now, but it gives you the option of lowering the amount of super sampling or overdraw. It's super common for us to render about 130% of the necessary pixels for a frame and then scale them down. However, when MSAA comes in, it's powerful enough, it cleans things up enough that we could probably cut that down to 110%. So you'd have fewer pixels that you had to draw, which is obviously a bonus. It also can give you per object screen space reflections. So if you haven't noticed in the deferred render, screen space reflections can still look a little wonky. This can clean these up a little bit. But again, it's more of a question of your desired visual quality and if your content is right for it. Just keep in mind, there is no such thing as a make it faster button in Unreal Engine 4. That's a lie. We come across them like once every couple of months, but we just set them to true and we remove them from UE4. It doesn't happen often. Now, this is probably like the parting shot I would leave you with just in terms of the forward renderer, just to give you an idea of what's coming. Because right now, you might have actually seen, if you've been playing around in the engine and you went into project settings, you might have actually seen the checkbox for the forward renderer, and you might have already turned it on at some point. Which is great, but right now I think that checkbox, all it will really do is turn off the gbuffer and nothing else. So that's not super useful. MSAA is not fully implemented as of 4.13. All of the features that we've been working into Robo Recall are not quite there either, but it's coming very, very soon. So why would you choose one path versus the other? So the deferred renderer gives you access to the gbuffer. It gives you more flexibility. It will always be our fully featured render. It's going to have all of the features that we're developing. However, if you've already been playing with VR Unreal Engine 4, you might have noticed things like temporal AA will tend to make some content look softer, maybe a little smokier. It's actually really good for organic environments. If you've got something with a lot of trees and rocks and cliffs and grass and things like that, it can actually really, really help you out. But it's not right for all kinds of content. If you need the sharper pixels from MSAA, if you don't care about shader flexibility, or maybe your content just doesn't require all the features of our full renderer, then you can consider Forward. But keep in mind, like one of the reasons we're switching to Forward for Robo Recall is if you guys haven't seen the trailer, which you will shortly, Robo Recall is very architectural, right? There's a lot of straight lines and a lot of angles and sharp objects where, even you get that slight line that starts to get really staggered, and you really need to clean that up. So it's more of a question of if your content is right for the forward renderer, then you should use that. If your content speaks more toward a deferred rendering path, make the right call. And any boost you get to performance from the forward renderer, think of that as a bonus. So what are some fun things that you can play with right now? Some of you might have already looked at some of this stuff. Perhaps not, so I'll just kind of go through this at a mega high level. So first off, Blueprint, HMD, and motion controller setup. If you haven't yet done it, it's actually very easy to architect the basis for a VR experience inside of the Unreal Engine. You can create a pawn, you can drop in a camera, you can drop it into a world and possess it, and it's already going to follow the HMD. So if you just want a stationary look around a really cool environment experience, you can prototype that in about 7 or 8 seconds. If you want to add motion controllers, the time jumps up to, I think, 30 seconds. You need to add a motion controller for each hand. Make sure you set one of them to the right hand, and you're pretty much done. If you need to add any kind of a mesh to that, you just parent the meshes in and all of that. It just works. The idea is that we've gone out of our way to try to make this process as painless as possible and enable you to build this content once and then deploy it to whatever VR platform you like moving forward. We also have a VR editor, which started out, we actually unveiled this earlier this year at GDC. This is live as of 4.12 and 4.13. It's just improving and getting better and better. This began its life as a collaboration between Epic Games and Stanford University. So they actually had 2 teams of students who were exploring the concept of building content entirely inside of VR. And they took 2 really, really different approaches. One of them was very much hardware-driven with armatures and whatnot. The other was a lot more software and Kinect capturing kind of stuff. But we took kind of the best of everything they'd put together, brought it back into Epic, and we've been continuing to develop it ourselves. And it's important, I feel, to discuss our primary goal with the VR editor. We're not trying to sell this as the be-all, end-all, here's how you're going to make your content for VR entirely in VR, because there are processes, there are points of the game development world that are just not ideal for VR quite yet. You're not going to open up Visual Studio in VR and code for an hour. You're not yet going to spend a whole lot of time in Maya rigging characters and whatnot. We may get there, but that's not where we are right now. So our goal is to help you out with like the first and last 20% of development. If you haven't yet played with the VR editor, you should. It's very cool. And you will find that the ability to jump in and like gray box out an environment entirely within the HMD is pretty neat. As you get close to the end of your project, you will also find a benefit in being able to put on the headset, grab your controllers, get yourself into the space, like feel that presence, and then look around and go like, that podium is in totally the wrong location. Let's just move it over here. And do that right at the very end as kind of a final tweak. And that's kind of how we've been driving our efforts for the VR editor. Now, we have a lot of exploring left to do. We're still working out new workflows, what actually works best in VR. Currently, our approach is just to take panels of the existing Unreal editor and make them as virtual panels that float in space. And that's right for some tools, and we've discovered it maybe isn't right for all other tools. It turns out text can actually be pretty hard to read in VR. And we're trying to find the best way to approach some of these problems. But we're looking at ways to apply material editing, level scripting. We want to get sequencer support in there so you can start creating movies and cinematics in VR if you so choose. Now, we've also added a VR template, which, again, if you haven't played with this, and you should, it's very cool. It makes it very easy to prototype out your VR experiences. This includes a map that already has a proper camera and motion controller pawn already in it and ready to go. The motion controller pawn already has teleporting and the ability to grab stuff in a very simplistic blueprint setup, so it's very easy to swap things out, move around, like add in your own geometry and pick that up instead. It can really, really speed up the process if really what you want to do is jump in and try something out and see if it's going to work for you in VR. This also works hand in hand with the VR editor, which is actually a lot of fun. You can jump in, you can play, teleport around, pick stuff up, and throw it, and you're like, oh, crap, I want to try that a little differently. If you hit the grip buttons, the triggers, and then click the sticks at the top, that'll actually stop playing and take you right back out to the editor. So you can move stuff around, then play again, jump back and forth. It's very, very cool. Currently, this is a blueprint-only template. So really quick, I want to throw in a blurb about where you can go to learn more about using Unreal Engine. And from there, I imagine that text is like way too small to read, maybe not. So we have our community answer hub, which is answers.unrealengine.com. Of course, our forums. I'm not going to read all of the web addresses because it's mostly just variations on a theme. It's forums.unrealengine, docs.unrealengine for our documentation. We have a wiki with a lot of tutorials. We have, of course, Twitch streams and YouTube training videos you should definitely check out. And my favorite thing, actually, is on the Unreal Engine launcher, when you download it, please make sure you check out the Learn tab, where you can go to download a lot of sample content that we've put together to help you learn how to use the engine. If you forget about it, try to remember the project content examples. It's like my favorite project we've ever released. And if you forget everything I just said, just go to unrealengine.com/support. That one's pretty easy to remember, and we've got everything listed off there. So with all of that, I do want to just kind of mention briefly how all of this kind of comes together, all of these features, all of the support that we're pouring into the Unreal Engine, and the inspiration that we get from folks in the community who are using the tech in ways that we hadn't imagined, adding pull requests to GitHub to help us make the tools even better, how that all comes together in our latest announced game, Robo Recall. So let's take a look at this trailer.
Say hello to the latest member of the Robo-Ready family. Presenting the TAL Series 9. Every bolt, every component has been meticulously designed. TAL will obey any command. It lives to serve.
Serve this.
We are now getting reports of sudden robot violence.
TAL features convenient transport handles,
Why did they add handles?
as well as easily replaceable parts,
Hey, I'm willing that.
and is built from impact-resistant materials.
Booyah!
Trouble-free service is guaranteed by our Robo Recall program.
What now?
Robot heaven, I see it.
Unstoppable.
Making your life better, one robot at a time.
Robo Recall!
So I can't wait for you guys to get your hands on that game. It is so much fun. If you have any opportunity to play it here at the show, make sure you do catch the demo.